Hi guys, today we're going to continue our operation on functions unit. To be more specific, we are going to focus on the difference and quotient on subtracting and dividing functions. So let's go ahead and do this. So we are given two functions, namely f of x equals 2x minus 7 and g of x equals 9 minus x squared, and we are asked to subtract and divide them. And not only that, when we're done, let's go ahead and list their domains. So remember, no matter which of the four operations you do, whether you add, subtract, multiply, or divide, whatever that outcome is, we still need to respect the domains of the original functions. So let's go ahead look at function f. So function f is a polynomial function. We don't have a radical or a fraction, so the domain is going to be given by the set of all real numbers. Okay, so all real numbers. Cool. Problem G. Function G is same speech. We have another polynomial function. We don't have a radical or a fraction, so the domain is also going to be the set of all real numbers. There's no need to write it two times. So this is pretty nice. Okay, cool. So we are asked to find f minus g of x. We need to have a clear idea of what we are being asked to find in order for us to have a fair shot. So in this case, we're going to take the first function, namely f. F is a function of x. The operation is minus, so we're going to subtract from it the second function, namely g, which happens to also be a function of x. So let's do this. So according to the problem, we have 2x minus 7, and then we're going to subtract from it the second function, which is 9 minus x squared. So I know what I meant to write. I meant to write this function minus that other function. But let's look at what we are subtracting. On my paper, I can't speak for you because you're awesome. On my paper, the only thing that I'm subtracting is whatever immediately follows the subtraction sign, which is a 9, and not the entire 9 minus x squared. So don't forget to wrap it up. Cool. So now we're subtracting the entire 9 minus x squared. So let's go ahead write this subtraction as a related multiplication, as a related addition problem, or we can say bad math, distribute the negative. No one's gonna know how you digest it. So that will give us 2x minus 7. When we add the opposite of a positive term is a negative term. Opposite of subtracting x squared is adding x squared. So I think we nailed it. Let's go ahead, write down these terms in descending order. We only have one squared term. We only have one linear term, or one x term. And when we combine the constants, negative 7 minus 9 will give us negative 16. And because there is more than one problem in this fun problem, I want to tell the reader, hey, what equals x squared plus 2x minus 16? We want to tell the reader, oh, it's the difference. Okay, so f minus g of x equals that. We box it and move on, but don't forget we are asked to also indicate the domain. So in this case, we have a polynomial function. We don't have a radical, we don't have a fraction, so the domain is also given by the set of all real numbers. But the question is, how do we write all real numbers in interval notation? I don't have that memorized because I try to memorize what I have to, but understand as much as I can. I can quickly build the interval. So let's go ahead graph the set of all real numbers. So this is a line. When we highlight a number on it, then we have a number line. I'm going to go ahead put 0 because we're on it. The domain is given by the set of all real numbers. So let me go ahead graph the entire number line, and then with confidence it's like, okay, interval notation goes from left to right. So we're coming from the negative side, and we're stopping at nowhere, but we're pulling towards the positive side. So in interval notation, the interval is given, the domain is given by the interval from negative to positive infinity. Cool, exciting. So let's go ahead and knock out problem B to wrap up this fun problem. So problem B, we are asked to find, where am I? F fraction bar G of x. So remember, the fraction bar is also used as a division symbol. So this is asking you to take the top function and divide it by the bottom function. So let me go ahead and write it so f and g are not like together. Okay, so we're going to take the top function, which happens to be a function of x, and then we're going to divide it by the second function. So in this case, we're going to go ahead divide. We're not really going to do the long division. We'll just set it up in as a quotient. Okay, so function f, where am I? Function f is given by 2x less 7. Function g is given by 9 minus x squared, and that's the end of that. So let's go ahead, tell the reader what equals that, and in this case, oh, it's the quotient that equals that. But bear in mind that we are also asked to indicate the domain. So from the beginning, we have said that domain of both f and g is the set of all real numbers, but the domain of our quotient is not the set of all real numbers. We have a fraction, so it's going to be all real numbers except for those that make the denominator a 0. And so what I want to know is what makes the denominator 0. If we want to know what makes the denominator 0, let's go ahead, take the denominator and set that equal to 0. I didn't want to tag it, but it's okay. I'm worth writing this over. Okay, we are worth. Okay, so if we want to know what makes the denominator 0, we're going to take the denominator and set that equal to 0. So if you solve this however you like, I'm going to go ahead, add x squared to both sides. And that will leave us with 9 is equal to x squared. You handle it however you like. If we use the square root property, when we square root both sides, don't forget to put the plus or minus. We're supposed to say absolute value in a later statement, but this will allow us to get to the answer a little bit more quicker. So that will give us that the square root of x squared simplifies to x, and we have x equals plus or minus 3. So what is the moral of this story? We wanted to know what makes the denominator 0. And in this case, what makes the denominator 0? Oh, it's positive 3 or negative 3. So we want to tell the world, x could be anything except for positive 3 or negative 3. So what is the domain? The domain of f and g are both the set of all real numbers, but the domain of the quotient is not the set of all real numbers. It's all real numbers except for the ones that make the denominator 0. All real numbers except for 3 or negative 3. And I know you're on it, but it's very hard for me to go straight to interval notation. Like, how do I write the interval for all real numbers except for 3 or negative 3? I have no time to try to visualize that. I might as well go ahead, graph the element in the domain. So we're going to go ahead, write a number line. Right now it's just a line. We're going to highlight those numbers that the variable cannot equal. So we're going to do open circles. So x cannot equal 3 or negative 3. What did we say the domain was? The domain of a rational function is the set of all real numbers except for those that make the denominator a 0. So we're going to graph the entire number line with the exception of these two. Fantastic. So let's go ahead, write that in interval notation. So let me go ahead, write down what the quotient is. So the quotient of f and g is given by 2x minus 7 over 9 minus x squared, where the domain is given by, we have 3 pieces, so we're going to have 3 separate intervals, and we'll connect them with the union symbol. So the first interval is all the numbers that are under negative 3, where negative 3 is excluded. So it'll be from negative infinity to negative 3, where negative 3 is excluded. Union, all the numbers between negative 3 and positive 3, where both endpoints are excluded. So it's the interval from negative 3 to positive 3, where both endpoints are excluded. Union, all the numbers that are bigger than 3. So the interval is from 3 to infinity, where 3 is excluded. So we answered the quotient. We stated the quotient. We stated the domain. So we're good. You don't have to box them together. If it's easier for you, you can box them separately, but I'm an overachiever, so I like to put them together. Okay, guys, so that's the end of this set of exercises. Thanks.